Hello. In this video, I'm going to explain about two-port networks. Two-port network means you can see the diagram here. So this is a two-port network where we have input port left side and right side we have output port. So there are four terminals are there. Input two terminals are input, output side these two terminals are output. So we collect as one port here. This is another port. So this is a two-port network. Single port means it will have only one port left side. So a two-port network has two pair of terminals. Okay, this is input and this is output, and you can see four uh, variables are there. Input side we have input voltage. V1 is input voltage, and input side current is I1. V1 and I1 are the input variables. Input voltage, input current. Similarly, at the output side we have output voltage V2 and output current I2. You have to observe the direction of the current. I1 and I2 both are going towards the two-port network here. I1 is also going into this network. I2 is also going to the network. And V1 plus here minus here. V2 plus and minus here. So these are the four variables. V1, I1, the input side. V2, I2, the output side. Now you can express two of these variables. Okay, you can express two of these out of these four. V1, I1, V2, I2. Out of these four variables, you can express any two variables in terms of other remaining two. So total four are there. Out of four, you can express two in terms of other two. So four combinations are there. You can have, I think, six combination. The number of possible combinations are 4C2. Okay, it is you are going to get six possible combination. The possibilities are you can express out of four here V1, V2, I1, I2. We can express V1 and V2 in terms of I1 and I2. That means input voltage and output voltages are expressed in terms of input current and output current. Or you can also express input current and output current are expressed in terms of output voltage and input voltage and output voltage. Input voltage and input current are expressed in as output voltage and output current. Similarly, V2 and I2 are expressed in terms of V1, I1, and V1, I2 are expressed in terms of I1, V2. So there are six combinations. So these are the six combination where we can express two variable in terms of other two. So for your syllabus, four uh, parameters to you have to study two-port parameters. That is Z parameters. That is also called as open circuit impedance parameter, where we are going to express voltages in terms of current. Voltages in terms of current. So write V1 and V2. Write V1 and V2. Here you have to express V1 and V2 you have to express in terms of I1 and I2. Write I1, I1 here, I2, I2 here. So V1 you have to write I1 plus I2. So what is there? This is Z11. So we have to express V1 is equal to some parameter into I1 plus some parameter into I2. That is called as Z11. So why it is called as Z parameters only? I will tell you. Okay, it is called as open circuit. This open circuit Z parameters are impedance parameters. Similarly, short circuit admittance. Admittance means reciprocal of uh, impedance. So it is we are to here we expressed V1 and V2 in terms of I1, I2. Here we have to express I1 and I2 in terms of V1, V2. So here the left side you have to write I1 and I2 in terms of V1 and V2. Both I1 and I2, left side V1, here V2. It express in terms of V1 and V2. Similarly, transmission or ABCD parameter, it is also called as ABCD parameter. It is also called as ABCD parameter. Transmission are called as ABCD parameters. Now, here in the ABCD parameters, we are expressing input side. This V1 and I1 belongs to the input side. V1 and I1 are expressed in terms of V2, I2. Okay, input side parameters are expressed as output side parameters, and only in T parameters or ABCD parameters, So we are expressing current as minus I2 because it is used in the transmission line. So where we are considering I1 and I2 is going right side actually. So it is opposite to the two-port network. That's why we have to write only for T parameters, you have to express minus I2 here. So V1 and I1 are expressed as, first you have to write voltage and the right side current you have to write minus I2. Okay. So parameters are A, B, C, D. And one more parameter you have is hybrid parameters where actually these are inputs are expressed as output current, input voltages are expressed as in terms of currents. We are going to express I1, I2 in terms of V1 and V2. Here we are expressing input side parameters, that is V1 and I1 expressed in terms of V2, I2. In the hybrid, input side 1, output side current. Input side voltage, but output side current. So it is hybrid. It is not same. Input side voltage we are taking, but output side we are taking current. So it is a hybrid. It is expressed in terms of I1 input side current and voltage. So first you have to write I, next you have to write V for hybrid parameters. I1 you have to write first, V2 you have to write. But in transmission parameter, I2 is minus. Okay, so I2 should come at the end. Okay, remember this if you make mistake, you will get wrong answers. So now let us see why it is called as open circuit impedance parameters. Just remember you have to make a note a table here. So we are having in the open circuit impedance parameter, we are expressing V1 and V2. We have in the two port four variables V1, V2, I1 and I2. We can express two in terms of other two. So out of that, we are writing now voltages V1 and V2. We are expressing in terms of I1 and I2. So write V1, V2. Okay. I1, you write I2, you write here Z11, Z12, Z21 and Z22. This also how to remember means first element in like in matrix writing first column first row no Z11 next to first row second column so 1 2 next to second row first column Z21 Z22. This is Z11 Z12 Z21 Z22. So first you have to write V1 next V2 here right side both I1 I1 here also I2 I2. So here variables are Z11 Z12 Z21 Z22. Now let us see open circuit impedance parameter. Simply it's called as also it's called as Z parameters. So Z parameters are expressed are maybe defined by expressing two voltages, two port voltages V1 and V2. Voltages are expressed in terms of currents I1 I2. So V1 V2 is equal to function of I1 and I2. So write V1 and V2 is equal to Z11 I1, Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. So V1 and V2 are expressed in terms of here you can see I1 I1 I2 I2. So V1 and V2 are expressed in terms of I1 and I2. So now I want to find what is this Z11. So I can express if I write this in form of these two V1 and V2 are expressed in terms of I1 and I2. Later I can write in the matrix form. So left side V1 and V2 and these four variables are Z11, Z12, Z21 and Z22 are the Z parameters and these I1 and I2 we can write here. So it is nothing but V is equal to this is impedance, this is current. V is equal to I into R. R in terms of impedance. If it is a DC network, we call it as a resistance. Here it is impedance Z. So that's why V is equal to I into Z. So this is impedance. Okay, that's why it's called as Z parameters. So why it is called as open circuit Z parameters or impedance parameters means. So in order to find one impedance, say one parameter here, Z11, I want to find Z11. I want to find Z11 and Z12 and Z21 and Z22. So first let me make, I want to find Z11 no. So let me have only this much. Okay. And I will make I2 is equal to 0. In this two port network, okay, if it is shorted, I some current will be there. Output side, if it is shorted, then closed path will be there and some current will be there. If you don't connect anything across this, it is called as open. Now if you don't connect anything here. Load if you don't connect, I2 is equal to 0. Because of open circuit, I2 becomes 0. So now we are making I2 is equal to 0. We are making this I2 is equal to 0. Okay. So when the output terminal is open circuited, so remember this circuit. Always you have to remember this circuit, two-port network. And if the circuit is open, I2 is equal to 0. If this output terminal is shorted, then V2 is equal to 0. When you short two terminals, voltage becomes 0. When you open these two terminals, current becomes 0. So how to make I2 is equal to 0? You have to open it. To make V2 is equal to 0, you have to short these two terminals. Okay, short circuit means zero resistance. Zero resistance into some current is equal to 0. So voltage becomes 0 when it is short circuit. Current becomes 0 when it is open circuit. So now when the two terminals are open circuited, the output circuit are open circuited, I told now I2 is equal to 0. When I2 is equal to 0, this part, when I2 is equal to 0, this is 0 now. So Z11 is V1 by I1. Input voltage by input current. So V1 by I1. Condition is what? When I2 is equal to 0. When I2 is equal to 0, when I2 is equal to 0, when output port is open circuited, current in the output becomes 0. When current becomes 0, this term is 0. Then Z11 can be calculated by V1 by I1. So Z11 is equal to V1 by I1, where V1 is what? V1 and I1 are input side voltage by input side current. So that I can tell that this is your Z11. And similarly, this is your Z22. This is Z11. This is Z22. And from 1 to 2, we'll see what is that. Okay. Similarly, with I2 is equal to 0, with I2 is equal to 0, second equation also. This is equation number 1. Let us call this is equation number 1. And let us call this is equation number 2. Okay. If I2 is equal to 0, the I2 is equal to 0, we got Z11 is equal to V1 by I2. At the same time, Z21 is equal to V2 by I1 because this term is 0. This term is 0. So Z21 is V2 by I1. So Z21 is equal to V2 by I1. Output voltage by input current. So Z21 is V2 by I1. It is output voltage by input current. If it is input voltage by input current, we call it as input impedance circuit. So input impedance Z11 is called as open circuit because I2 is 0. We made I2 is equal to 0 by open circuiting output terminals. And it is a ratio of input voltage by input current. That's why it's called as input impedance. Similarly, with I2 is equal to 0, one more parameter from the equation number 2, Z21 is V2 by I1. So it is output side voltage by input current. So it is called as forward from input to output. We are calculating from output by input. So that's why it is forward. Forward transfer impedance. Output side voltage by input side current. That's why it is output by input. No, it is forward like this. Output side voltage, it is input side current. So it is moving forward now from this current and output side is, if you move forward, you will get this side output voltage by input current. That is, we call it as Z21. It is also referred as forward transfer impedance, and the unit is it is voltage by current. No, it is unit is ohms. This is also ohms. Similarly, we'll go for this. Okay, go for this. So again, I have to find out another two variables. Which are the another two variables? I want to find out what is Z12 and what is Z22. So in order to find Z12 and Z22, I want to make this I1 is equal to 0. I want to make this I1 is equal to 0. How to make I1 is equal to 0? In the two-port network, you make this input terminals open. When you make input terminals open, I1 becomes 0. And how to make V1 is equal to 0? You have to short. When you short, voltage becomes 0. Now I am not shorting, I am opening. When I open this, I1 becomes 0. When I1 is equal to 0, you can find remaining two parameters from the equation number 1. From the equation number, when I1 is equal to 0, this portion is 0. Okay. Now this portion is 0. Now I'm calculating Z12. Z12 is equal to V1 by I. It is input side voltage by output side current. Okay. Similarly, when I1 is equal to 0, Z22 is V2 by I. Yeah, V2 by I. So which is output side voltage by output side current. So it is called as output impedance. It is output impedance because both belongs to output side. But this one, Z12, it is input side voltage and output side current. It is voltage is input, current is output. So it is reverse. So it is reverse transfer impedance. Okay, Z12 is input side voltage, output side current. So it's called as open circuit reverse. Output side voltage by input side current is forward. So like we got for 21, Z21 we got output voltage by input current, that is a forward. But here side voltage, output side current, so it is a reverse transfer impedance. Its unit is also okay impedance. All units are impedance. So it is also output side when you make I1 is equal to 0, V2 is equal to sorry Z22 is equal to V2 by I2. It is output voltage by output current with I1 is equal to 0. So all you can see Z11, Z21, Z12, Z22, all are ratio of voltage by current. So that's why it's called as impedance and its unit is ohms. Okay. And why it is called as open circuit means I have to make we expressed V1 and V2 in terms of I1 and I2. We expressed V1 and V2 in terms of I1 I2. So in order to make I1 or I2 is equal to 0, in order to make I2 is equal to 0, output side should be open circuit. In order to make I1 is equal to 0, input terminal should be open circuited so that you can find Z parameters. So this is about Z parameters. So after that, from this equation, okay, V1 is equal to, it is a sum of this drop plus this drop. It is I into Z plus I into Z. So V1 can be modeled as, so V1, you can apply KVL here. You can apply KVL here. So V1 is equal to I1 into Z1 plus uh, I2 into Z2. I1 into Z1 plus I2 into Z. So Z11 into I1, Z12 into I2. So this is pure uh, impedance here only, but this is a dependent source. Okay, is a dependent source plus minus is there now. So it is depends on this voltage depends on the current in this. Okay, if this current is zero, then this becomes zero. Okay, so it is expressed as dependent diamond shape. This is Z22. Input impedance is Z11, output impedance is Z22, and remaining two you have to express like this. So this is equivalent circuit for Z parameters. So output side if you write a KVL, you will get second equation. Input side if you write a KVL, this okay, this voltage is equal to sum of this plus this. So current in this path is I1, Z1 into I1, and this is a voltage source. This is a voltage source. Directly you can write Z1 to I2. Okay, similarly, right side V2 is equal to Z22 is the impedance. Okay, Z22 into I2 plus Z21 I1. Okay, now in the next video I will explain how to solve problems on this. Okay, thank you.